let us begin our today's session. In the previous class, we have discussed about the planes. So I want to take some other concepts on planes. Then we start with our new topic, that is right line. So that will be the objective of today's session. So do you have any queries with regard to planes, the topics what we have discussed earlier? Right. Then let us take the other problems with regard to planes. The question is, find the locus of the point whose sum of the squares of its distance from the planes x plus y plus z equal to 0, x minus y equal to 0, and x plus y minus 2z equal to 0 is 7. So find the locus of the point whose sum of the squares of distances or its distance from the planes is 7. So read the question part. If you have any other queries, you can ask. After noting the question, please tell. So here you are going to find the locus of a point. So let us take that x1, y1, z1 is the required point. So you are going to find the condition, nothing but locus satisfied by that point. It is given that if you calculate the distance from the point to each of the planes, distance from the point to the first plane, distance from point to second plane, and distance from point to third plane, you calculate the three distances. Then if you find sum of the squares of the distances, it will be equal to 7. That was the question part. Fine. Are you getting the idea? So as we know, whenever a point is given and a plane is given, if you apply the distance formula, so if you calculate the distance between these two, it is modulus of 1 into x1 plus 1 into y1 plus 1 into z1 by square root of 1 plus 1 plus 1. Similarly, for the second one, if you calculate the distance 1 into x1 minus 1 into y1 modulus whole by square root of 1 plus 1, and here the distance is 1 into x1 plus 1 into y1 minus 2 into z1 modulus whole by square root of 1 plus 1 plus 4. So it is nothing but distance from point to the plane. Now you have to consider square of the distance and we have to add them. The result is nothing but 7. So if you apply that, x1 plus y1 plus z1 whole square whole by 3 plus x1 minus y1 whole square whole by 2 plus x1 plus y1 minus 2z1 whole square whole by 6 is equal to 7. So the rest of the part is nothing but simply calculating the LCM and simplifying the expressions using a minus b whole square as well as a plus b plus c whole square. So are you able to do that, the simplification? So I want to write the final conclusion. So you are going to get it as 6x1 square plus 6y1 square plus 6z1 square, then is equal to 42. So if you cancel x, x1 square plus y1 square plus z1 square is equal to 7. Hence the required locus is nothing but x square plus y square plus z square equal to 7. So that was the required locus, satisfied by the point. Please take a note of it, right? The next one is So please take a note of the problem. So here it is considered that a variable plane is at a constant distance p from the origin, and while moving it intersected the axis at the points A, B, C. So you have the x-intercept A, y-intercept B and z-intercept C. So by default we need to assume that. Now it is further given that, so for those intercepts or from those intercepts ABC, you have to draw the planes which are parallel to the coordinate planes. It means that from the first point A, you are going to calculate the equation of a plane passing through A and parallel to coordinate plane. Similarly, from the point B, you are going to calculate the equation of a plane passing through B and parallel to coordinate plane. Like that, so from the 3 points, you are calculating 3 planes which are parallel to the coordinate planes. So from that point of view, the 3 planes will intersect. So the intersection of 3 planes is nothing but a point. So you have to show that the locus of the point of intersection satisfies that equation. That was the objective of the question. Fine. Anyone wants to elaborate the idea again? Or is it sufficient? Are we getting the concept here? Right? Now, if you consider the variable plane, since it is meeting the coordinate axis at the points A, B, C, so by default we take that capital A0, 0, this is the x-intercept point, capital B, 0, B, 0, y-intercept, and capital C, 0, 0, C, z-intercept. So if we have written the equation of the variable plane in the intercept form, it is nothing but x by a plus y by b plus z by c is equal to 1. You can write it further as 1 by a into x plus 1 by b into y plus 1 by c into z minus 1 equal to 0. This is the plane equation which is meeting the coordinate axis. Now what happens? The distance from origin to this plane is nothing but p. It is given here. So if you calculate the distance of 0, 0, 0 from this plane, it is nothing but p. So if you apply the distance formula, so you have modulus of 0 plus 0 plus 0 minus 1 whole divided by square root of 1 by a square plus 1 by b square plus 1 by c square is equal to 2p. Any queries for anybody at this point? So for simplification, let us take squaring on both sides and do the reciprocal. Then you have 1 by p square is equal to 1 by a square plus 1 by b square plus 1 by c square. So please take a note of it. Then I want to move with the second part of the question. So up to this part, I get an equation of this form. 1 by p square is equal to 1 by a square plus 1 by b square plus 1 by c square. From the first two lines of the problem, I have this deduction. From the next line onwards, I want to do the remaining part. Okay? After noting this, you tell. Right. Now, if you read the second part of the question, it is given that through the points A, B, C, planes are drawn and those planes are parallel to the coordinate planes. So let us take the first point A00. 0. Now this point lies on the x-axis, right? So just imagine if this is a point on x-axis, I have considered a plane passing through it. And this plane is parallel to the other plane. Right? So from that, what we can say, about that parallel plane, because we have three coordinate planes xy, yz and zx. So the plane which you are considering must be parallel to one of the three planes. So among xy, yz and zx, to which plane it will be parallel? Any guesses? That will be yz plane. So is everyone imagining the thing or not? Because for your idea, if you have a small doubt, take 3 pens, arrange them mutually perpendicular. So if you feel that this is x-axis, you consider a plane passing through it. You put a paper on this line. So this must be parallel to one of the three planes. So this will be xy, this will be yz and this will be zx. So if you observe that the plane what you have taken is parallel to yz plane. So what is the equation of yz plane? It is nothing but x equal to 0. So you are finding the equation of a plane which is passing through this point and it is parallel to the plane x equal to 0. So whenever you talk about parallel planes, obviously you say that the plane equation which is parallel to this one is nothing but x is equal to k. Agreed? Is everyone getting the context? Right. So since this plane also contains the point a00, you substitute a00 there. Then you will get k is equal to a. So observing these two, we conclude that x is equal to a. You can take the constant as either positive or negative, anything, right? So x plus k is equal to 0, right? X is equal to k is the right answer. The plane parallel to x is equal to 0 is x is equal to k. It is just like, suppose I have taken a line equation, say 2x plus 3y is equal to 0. So if you want to write a line equation which is parallel to this one, it is nothing but 2x plus 3y is equal to k. Accepted? So this is my line equation. If you want to write a line equation which is parallel to this one, so whenever you talk about parallel lines, coefficients are same, constants will differ, isn't it? Just like that, x is equal to 0 is nothing but a plane equation. If you want to write a plane equation which is parallel to this one, so coefficients must be same, constant should vary. That's why I have taken x is equal to k. Clear? Yes or no? Yeah. So in this plane equation x is equal to k, please understand that the plane equation x is equal to k has two properties. The first property is it is parallel to yz plane whose equation is nothing but x equal to 0. The second property is it is containing the point a00. So if you substitute a00 in place of xyz, it will be satisfied. So substituting a00 in that point, you will get k is equal to a. So You obtained two relations that x is equal to k and k is equal to a, comprising which you will get x equal to a. Fine. Is the objective clear to all? Similarly, since I did one part with the first point, similarly I will take 0, b, 0, the second point. I will consider a plane equation which is parallel to the coordinate plane. Using the same technique, you will get the plane equation as nothing but sum y is equal to k. And as usual, the final answer, observing these two equations, you got that x is equal to a, so here you will get that y is equal to b. Similarly, for the third point, you will get that z is equal to c. Are you getting the idea? Earlier you have taken yz plane, so in the second case you will take xz plane, in the third case you will take xy plane. So equation you will write z is equal to 0, parallel to means z is equal to k. So substituting the point 0, 0, c, you will get k is equal to c. Hence you will get that z is equal to c. If you have a small doubt, so in a small nutshell we can write like this. You have done 3 cases here. So in the first case, I am going to find a plane equation which is containing the point a0, 0 and parallel to coordinate plane. Here the coordinate plane is nothing but yz plane. So its equation is nothing but x equal to 0. So what happens? Parallel means x equal to k. Substituting the point, you will get that a is equal to k. So concluding these two, you will get x is equal to a. For the second case, you are going to calculate the plane equation passing through the point 0, b, 0 and parallel to coordinate plane. Here the coordinate plane is nothing but xz plane, whose equation is nothing but y is equal to 0. Therefore required plane is y is equal to k. Substituting the point 0, b, 0 there, you will get b is equal to k. From these two, you will get y is equal to b. Similarly, for the third thing, you are going to find a plane equation passing through the point 0, 0, c and parallel to the coordinate plane xy plane, whose equation is nothing but z is equal to 0. So required plane equation is nothing but z is equal to k. In this, if you substitute 0, 0, c, you will get z is equal to c. Sorry, k is equal to c. Combining these two, you will get that z is equal to c. So you got that x is equal to a, y is equal to b and z is equal to c. So if you write the point of intersection, x, y, z is nothing but a, b, c. So earlier you have written an equation that 1 by p square is equal to 1 by a square plus 1 by b square plus 1 by c square. In the distance formula, you have deduced something. So in that ABC, if you have written x, y, z from this perspective, you got that 1 by p square is equal to 1 by x square plus 1 by y square plus 1 by z square, nothing but our required locus given in the problem. So that is the way to solve this one. Any queries to anyone? So if we have noted this, then I will take the other model. So is the approach clear to all? Fine. So the next one is very similar to this model. Let us do it again. So please take a note of it. So the difference between the previous problem and the current problem is, in the previous problem you have taken a variable plane and having a distance from origin. The second part of the problem is very similar. Locus of point of intersection of the planes passing through the points ABC and parallel to coordinate planes. The same part is extracted here. So apart from taking distance from the origin, here he mentioned that the variable plane is passing through a point alpha, beta, gamma. That is the only difference between the previous problem and the current problem. However, the locus will change automatically. Fine. Is the objective clear? Similar to the previous question it is. The second part if you read. Now, the first part will be done very easily. So you take a variable plane. Since he mentioned that it is meeting the coordinate axis in ABC, as usual, you take that A00 x-intercept, 0B0 y-intercept, 00C z-intercept. Obviously, the equation of the plane is nothing but x by A plus y by B plus z by C is equal to 1. So I have written the equation of the plane in intercept form. In the first line, it is given that the plane is passing through a point alpha, beta, gamma. In other words, if you substitute alpha, beta, gamma, the plane equation gets satisfied. So substituting alpha, beta, gamma in place of x, y, z, you have that alpha by A plus beta by B plus gamma by C is equal to 1. Any doubts to anyone? Right. For the second part, we exactly take copy and paste of the previous problem. I have bifurcated the three cases: passing through the point A00, parallel to the coordinate plane, YZ plane. Equation is x equal to 0. So parallel plane is nothing but x equal to k. If you substitute that a is equal to k, combining these two, you will get x is equal to a. Clear? In the previous problem, you have done the same thing. That is nothing but second part of the problem. Understand that planes through ABC and parallel to coordinate planes. Did you observe it? So, in the previous problem, you have proved x is equal to a, y is equal to b, and z is equal to c. The same things you put copy and paste, the exact thing, you will copy it. So, you will get that x is equal to a, y is equal to b, and z is equal to c. So, you will rewrite the proof of the second part of the previous problem here. So, substituting ABC values in this box, you will get the required solution. Which is nothing but required locus. So, if you understand the previous problem, this problem is nothing but a cakewalk. Accepted? Please take a note of it. Now, I just want to take a small concept which is calculating area of a triangle in the planes context. However, it is not that much important, but I will take 2 or 3 problems over this. Hence, we conclude our discussion with regard to planes. Okay. So, after the completion of planes, I try to give a practice assignment for you, which is comprising of all the basic formulas, etc., which will nourish your knowledge in getting the fundamentals grip. Right? Earlier in two-dimensional geometry, if we have taken the vertices of a triangle, x1, y1, x2, y2, x3, y3, I think we have a formula for calculating the area of triangle, right? Isn't it? Now, if you take the three-dimensional one, x1, y1, z1, x2, y2, z2, and x3, y3, z3, how to calculate the area of a triangle? So, that was the current thing. So, let us denote that delta is required area of the triangle, and its formula is given by square root of delta x square plus delta y square plus delta z square. These are nothing but the projections taken on the coordinate planes, YZ plane, XY plane, ZX plane respectively. Now, the formula for them is, if you want to calculate delta x, so since you are calculating with respect to x, in these ones you remove the coordinates x coordinates. So, you are going to evaluate the determinant please observe the pattern. So, delta x is nothing but half into the determinant value. If you have written delta x, you are removing the x coordinates in the given 3 vertices. For the remaining values are written. In place of x, I have taken 1, 1, 1. Okay. So, delta y is nothing but half into determinant of x1 z1, x2 z2, x3 z3, 1, 1, 1. I hope you will write delta z. Can you? Did you observe the pattern? Delta x means in the 3 coordinates I have removed x, I considered yz only. Delta y means in the 3 points I removed y, I consider xz only. Similarly, delta z, can you write? So delta is nothing but area of the triangle given by square root of delta x square plus delta y square plus delta z square. Please take a note of it. Let us do one small problem. I will give the problem, you can do on your own. You just give me the confirmation with regard to that. Yeah. So the problem is I have taken the vertices of a triangle as A 1 2 3, B value 2 minus 1 1 and C value 1 2 minus 4. So you have to calculate the area of the triangle ABC whose vertices are given like that. So obviously delta is nothing but area of the triangle given by delta x square plus delta y square plus delta z square. So I will write the respective values. Delta x is half into determinant of 2 3 1 minus 1 1 2 minus 4 1. So if you calculate the value, it is nothing but 21 by 2. I am not taking the decimals, I am taking the fraction. So delta y is half into 1 3 1 2 1 1 1 minus 4 1. If you calculate the value, it is 7 by 2. And delta z is half into 1 2 1 2 minus 1 1 1 2 1. So if you calculate the value, its value will be 0. Because we have first and third rows are equal. So from that you will calculate the area of the triangle. So just ask you to make sure that the determinant values what I have written are correct by doing yourself. After verifying the respective numbers, you give your confirmation, then I will take with the other models. So I request everyone to calculate the debt on their own. So while taking the square, it will become positive, right? Yeah. So obviously 1 by 2 into square root of 490 is the area, because 21 21 is 441, 7 7 is 49. If you add 490, you will get in the square root. So 1 by 2 will be taken out from the square root. So 1 by 2 into square root of 490 is the answer, square units. So is everyone clear with this approach? Fine. So let me take the other one. This is the problem. Answer for the previous one, 1 by 2 into square root of 490. Because 1 by 2 is common there. 441 plus 49, 490 is the value under the root. Please take a note of the question. After noting, please tell. Clear? So have you noted the problem? Right. So it is given in the problem that the plane has made intercepts x-intercept A, y-intercept B and z-intercept C. And here also you are going to calculate the area of triangle ABC. The answer is also given there. It is nothing but half into square root of b square c square plus c square a square plus a square b square. Using the same technique earlier, we will do the problem. There is no change at all. So if you take that delta is area of triangle ABC, then it is nothing but half into square root of delta x square plus delta y square plus delta z square. Now what actually delta x gives to us is nothing but delta x is the projection of triangle ABC on YZ plane. Delta y is the projection of triangle ABC on ZX plane. And delta z is projection of triangle ABC on XY plane. So sum of the squares of the three projections is going to give the total area of the triangle. That is the underlined idea. Okay? Are you getting the context? So if you visualize the picture, so x-intercept is capital A and it is given that the distance is nothing but A. Here the distance is nothing but B. The distance is nothing but C. Accepted? From the intercepts point of view. So if you talk about projection, delta x, if you consider the projection of YZ plane, it is nothing but half into the triangle taken on YZ plane, the area of the triangle. So area of the triangle I will write for convenience. So half into base into height. So if you consider this is the base and this is the height. So this is nothing but half BC. Okay. You can feel like this. This is the triangle. It has a base, it has a height. So area of the triangle is nothing but half into base into height. So half BC is the value. Similarly, for ZX plane, its area is nothing but half into AC. Can you visualize the part? X-axis is coming outside here. It is like this, coming outside. So A is the base, C is the height. And XY plane, its value is nothing but half AB, if you observe from the diagram. So substituting these values in the formula delta, you will get the required solution. Did you observe it? Anybody has any doubts over the approach? So if you are clear with this one, I want to take a similar kind of model. So please take a note of the solution, then I will discuss that. The next model. So sum of the squares is nothing but 1 by 4 into b square c square plus 1 by 4 into a square c square plus 1 by 4 into a square b square. So you are substituting all the three values under the square root. So 1 by 4 comes out, it will become 1 by 2. Because the formula is delta is equal to, see actually this is 1 by 2 is not there, right? The formula is just square root of delta x square plus delta y square plus delta z square. That is the only formula. Sorry, I misplaced half there. So 1 by 2 into square root of b square c square plus c square a square plus a square b square is the value. Fine now? Yeah. So the next one is Please take a note of the problem. So find the area of the triangle included between the plane 3x minus 4y plus z equal to 12 and the coordinate planes. It is very similar to the previous problem. So the thing is, in the earlier one, you know, a plane has made intercepts on the coordinate axis which are nothing but ABC. In other words, the points are taken on the coordinate planes. You have calculated the area of triangle ABC earlier in the previous problem. So, how the triangle is formed there? The triangle is formed by the plane which made the intercepts and the coordinate planes. Without that, you cannot take projections on the coordinate planes, isn't it? So, the previous problem and the current problem both are very similar. In the previous one, apart from giving the plane equations, straight away he has given the intercepts. Here, we need to find the intercepts from the given plane equation. Rest of the problem is very similar with regard to the previous one. Did you get it? What I said? Right. So in order to make the plane the conversion of intercept form, so divide with the constant. So 1 by 4 into x minus 1 by 3 into y plus 1 by 12 into z is equal to 1, nothing but x by 4 plus y by minus 3 plus z by 12 is equal to 1. Accepted? Yes or no? Hence, the x-intercept is nothing but 4. Nothing but you can say 4, 0, 0 is the point. Y-intercept is nothing but minus 3. Z-intercept is nothing but 12. So you can, if you give the names as A, B, C, so OA is equal to 4, OB is equal to minus 3, OC is equal to 12. So, as usual, area of the triangle is nothing but delta is equal to square root of delta x square plus delta y square plus delta z square. So, if we calculate delta x, half into base into height. So, for x, we should take yz plane. So, half into minus 3 into 12. Delta y, we take zx plane. So, half into z means 12, x means 4. Right. So, here the first one is 18 minus you will get. Here the value is 24. So, the other one is nothing but 6. Accepted? So, area is nothing but 3 root 26. So, the previous problem and the current problem are very similar in the approach. The only difference is, in the previous one, intercepts are given straight away. Here you have calculated the intercepts from which you have detected the area values. That is the only difference. So, any more doubts for anyone here? So, square root of delta x square plus delta y square plus delta z square, if you will do, the value is nothing but 3 into root 26. Right. So, here I want to conclude my discussion with regard to planes chapter. So, if you have any doubts with regard to the previous year questions, you can ask. I will give the postings randomly in the Telegram. Now, we start with the second chapter, that is right line or straight line, whatever you call. So far you have many definitions with regard to line. So here onwards we consider that line is nothing but intersection of two planes. So whenever you feel that I have a line equation with me, we need to understand that the line equation is obtained by means of intersection of two planes. So here the contents of the chapter, you can simply bifurcate it as finding line equations. In other words, from a given data, how to write line equation. Second one, image of a point and line in a plane. This is one small concept. Later we discuss about point of intersection of planes, nothing but point of intersection of lines. Then we talk about coplanarity of lines. Then we talk about skew lines, nothing but shortest distance. So this is nothing but the overview of the whole chapter right line. The key points we are going to give focus with regard to the examination point of view. It is nothing but the whole syllabus with regard to right line. Okay, take a note of that. So may I know, some of you have the basic knowledge with regard to these contents or not? Because whoever has studied coordinate geometry at +2 level might have the idea. Alright, so in today's session I want to give the basic definitions and some approaches. I don't want to discuss the problems now because we have done so many things with regard to planes. So tomorrow we start afresh with the problems with regard to right line. So let us refresh the contents with regard to right line. Now, can I erase those parts if you have noted them? Thank you. The very definition says that line is formed by the intersection of two planes. So, if you want to write the equation of a line, it is nothing but simply specify the two planes which are intersecting. So I will write that 2x plus 3y plus 4z plus 1 equal to 0, that equals to x minus y minus z plus 2. So please understand that I have supposed that these two planes are intersecting. So without writing the two planes separately, I have indicated them with a common 0. So by default, we need to assume that these two planes are intersecting. The intersection is nothing but a line. So here you are presenting the line form by means of the two planes. This type of notation, we call it as unsymmetric form. The next one is, suppose if this is the line you have taken, if you know a point on the line and the direction cosines of the line, so you are going to write it as so L, M, N are nothing but direction cosines of the line. X1, Y1, Z1 is any point on the line. So you will represent the equation of the line L like this. This type of notation, we call it as symmetric form. So since the values are proportional, you take them as equal to R, the proportionality constant R. So if you equate the first one with R, you will get that x minus x1 is equal to LR. It is nothing but x1 is equal to x1 plus LR. Similarly, making the remaining terms equal to the proportionality constant R, you can call R as a parameter. So you will get y is equal to y1 plus mr, z is equal to z1 plus nr. So this type of notation, we call it as parametric form. You might have known. So this is nothing but listing out all the coordinates on the line x, y, z explicitly. So for all the x coordinates, you have found an expression. For all the y coordinates, you got an expression. For all the z coordinates, you got an expression. So for different values of r, you are getting different points on the line. So this type of notation, we call it as parametric representation. There is one more thing, vector representation, which we don't do with regard to the problems. So I am skipping that. There is no need to learn the vector notation separately. Another thing is, whenever you know 2 points on the line, the equation of the line will be obtained using the formula so if we have taken that x1, y1, z1 is 1 point on the line, x2, y2, z2 is another point on the line, then you are writing the line equation using the 2 points in symmetric form, which is x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2 minus z1. Here the denominator values are nothing but direction ratios. So at this perspective, we can understand that we can write the line equation if you know the drs or if you know the dc's, whatever the case may be. And in the numerator, apart from x1, y1, z1, you can take x2, y2, z2 also. So numerator contains any 1 point on the line, denominator contains the direction ratios of the line. So that is also nothing but symmetric form. Clear? So please take a note of these forms, then I will move further. After noting, please tell. Any confusion for anyone here? This is called 2-point form. When 2 points are given, you are writing the equation of a line. So do you know image of a point do you know the definition or not? At +2 level, you know how to calculate image of a point with respect to a line. Could you recollect that? Or no idea? Or forgotten? Right? Then see, suppose you take a plane. I am indicating the symbol with pi. Pi is a plane. Now I have taken a point P. I wish to know what is the image of this point with respect to the plane pi. The definition is defined such that if the point what we have taken lies on the same plane, so if P satisfies the plane equation, so P is lying on the plane. Hence, the image of P is nothing but itself. P itself is the image. If the point you have taken is outside of the plane, say P is outside, that means P does not satisfy the plane equation. So if you draw a perpendicular line, this is the foot of the perpendicular, and you extend this. So to a point Q. So P is an external point to the plane. So from P you draw a perpendicular line which is passing through the plane. You extend that line to a point Q such that if this is the foot of the perpendicular, this is nothing but the midpoint of these two. And we say that Q is image of P. So this is the definition of image of a point. If the point is on the plane, its image is itself. If the point is outside the plane, then Q is called image of P. The M is midpoint of PQ, and M is nothing but the foot of the perpendicular which is lying on the plane. Okay? Clear? Please take a note of the definition. So here I calculated the image of a point with respect to the plane. Now I want to calculate image of a line. So image of a point and image of a line are two different aspects. So point image is nothing but point, line image is nothing but a line. So you need to calculate another line which is nothing but the image. So let us say that this is the plane pi. Then you take that this is a line L which is not there. So the image of L, we define it as, first on the line L you take a point P. For this point you calculate the image Q. Are you getting what I am saying? Now you need to find another point. So if you extend this line, at what point it meets the plane? Say this is Z. So you are saying that if I extend this line and make it passes through the plane, at what point it meets the plane? That point we are calling it as Z. Now this thing QZ is called image line for the given line L. That was the definition. So you have calculated two things here. One, the image point. Two, the point at which the line meets the plane. When you have 2 points, you know how to write equation of a line. I have given earlier 2-point form. X minus x1 by x2 minus x1 equals to y minus y1 by y2 minus 1 equals to. That formula we use and we will calculate the image of a line. So line image is nothing but a line, point image is nothing but a point. So there you are calculating a point, here you are deducting a line. That is the thing, and that is the procedure for the calculation of image of a line. Okay. So please take a note of the diagram. These two things are important. I think you have the minimum weightage of 12 to 15 marks for this kind of questions in UPSC earlier. That's all for the day.